Impacts and collisions 2016A. We're given this diagram here with two smooth spheres hanging from a ceiling. A is mass 2 kilos, B is mass 3 kilos. The distance from the ceiling to the center of the ball is 2 meters. A is drawn back 60 degrees and released from rest. A collides with B and rebounds, and B swings through an angle theta. The coefficient of restitution between the spheres is 3/4. Part 1, you're asked to show that A strikes B with a speed of root 2g meters per second. Okay, well, let's have a diagram here for A to see what's happening. So here's A. It's swinging down to this position here. We have an angle of 60. We have 2 meters to the center of the ball. So it's going to go in there. So I've got a triangle going on here. So if I can get, I have two variables on this triangle here. Just continue that one in there. So I can get this side here. So I have got my hypotenuse and I'm looking for my adjacent. So the cos of 60 is equal to, call this x over 2. So 2 cos 60 is equal to x, and the cos of 60 is equal to a half. So x is equal to 1. So that make this length here 1 meter as well. They're both 1. So we're looking at potential, and the kinetic energy is 0. It's at rest at the top. So the potential energy is mgh. mgh, which is m by g, by the height above, which we've just worked out, this 1 here. So that's the potential energy, mg. And m is equal to 2, so it's going to be 2g. When it's at the bottom, A has kinetic energy of a half mv squared. And its potential energy, the height is 0, so the potential energy is 0. So a half by m, which is 2 by v squared, is the kinetic energy. So that's going to be just v squared. And we know that the energy at the top is equal to the energy at the bottom. So v squared is equal to 2g. And we were asked to show root 2g, so there it is, v is equal to the square root of 2g. In part 2, we're asked to find the speed of each sphere after collision. So speed of each is v1 and v2. So we're going to be using the principle of conservation of momentum. m1u1 plus m2u2 is equal to m1v1 plus m2v2. So filling our variables in, we've gotten the speed, root 2g, the mass of A, let's go back up, is 2, and the mass of B is 3. So 2 by the square root of 2g plus 3, it's at rest, 0, plus 2v1 plus 3v2. So 2v1 plus 3v2 is equal to 2 root 2g. Using Newton's experimental law, v1 minus v2 over u1 minus u2 is equal to minus e. We'll have v1 minus v2 is equal to minus 3/4 by root 2g minus 0. So 4v1 minus 4v2 is equal to minus 3 root 2g. We have 2v1, we can just, if we divide this line by minus 2, we'll be able to eliminate the v1s. So by minus 2. So minus 2v1 plus 2v2 is equal to 3 root 2g over 2. Bringing this one down, we're going to get 2v1 plus 3v2 is equal to 2 by the square root of 2g. So 5v1 is equal to 3 by the square root of 2g over 2 plus 2 by the square root of 2g. And if we divide all that by 5, we're going to get v2. And that will give me, on a calculator, 3.099. So we round that off to 3.1. And then to get v1, we have this equation here, just has v1 in it. So v1 is equal to minus 3 over 4 by the square root of 2g plus v2, which is 3.1. So I'm typing this into a calculator. Gives me minus 0.22. And put my units in, ms to the minus 1. So that's v1 and v2. Part 3, we're asked to find the value of theta, aren't we? I haven't written down yet. Find the value of theta. Let me write that down. So find the value of theta. So just let's draw a diagram for that one. Just go back up and have a look. We have theta in here. So it's the same, similar to the first question at the top here. We're going to have kinetic energy and potential energy. And the same at the bottom, so that's what we're dealing with here. So let's go down and draw this diagram. Again, we're going to have from the center to here. So let's draw that diagram. So we have my 3g, my 3 kilogram. It's going up to here. I have my angle theta. I have this line that will go from the center to give me this distance. Now we know that this is 2 meters to the center, so this one here, we say the cos of theta is equal to, we'll call it x over 2 cos theta is equal to x. So this distance, the height above, if I bring this down into the middle, the height above from here to here, it's going to be the total distance of 2 minus 2 cos theta. So that potential energy at the top, the potential energy is mgh, and this is why we need this for h. So we have 3 g by 2 minus 2 cos theta. Kinetic energy is 0 at the top, the potential energy is 0 at the bottom, and the kinetic energy is a half mv squared. So a half mv squared, we're dealing with v2 here, so we're dealing with the 3.1. So let's come over here. So a half by 3 by my velocity squared, 3.1 squared. Calculator, 1.5 by 3.1 squared is going to give 14.406. So we're going to say then these two are equal. So 2 minus 2 cos theta is equal to 14.406 over 3g. And that'll give me exactly 0.49. So just bring the 2 theta to the right and the 0.49, so we're going to get 1.51 is equal to 2 cos theta. So the cos of theta is half of that, 0.75 and a 5. So typing this into our calculator, the inverse cos of 0.755 will give me theta. So theta works out to be 41 degrees. Rounding it up from 40.97, so we leave it at 41.